Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called continuous subarray sum. We were given an integer array nums and an integer k. Return true if it has a good subarray or false otherwise. So a good subarray is defined as its length is at least 2 and the sum of all the elements in the subarray is a multiple of k. So with that said, let's take a look at example here. We have an integer array like this, and we have a k equals to 6. So the sum of the subarray elements will be a multiple of k. That means, let me write it down here. So suppose we have 23, 2, 4, 6, 7, and we have a subarray like this from 2 to 4. Its sum will be 6, and after modulated by 6 we will have 0. Okay, that means the sum of this subarray is a multiple of k. Okay, so yeah, that makes sense. So the brute force idea is to generate all the subarrays, so starting from 23 and then 23, 2, 4, 6, 7, and we calculate all the modulations, and we see if there's a good subarray or not. And then we start from 2 to generate 2, 4, 6, 7 to see if there's anything, and goes on 4, 6, 7, and 6, 7. Okay, so for brute force ideas, excuse me. So for brute force ideas, we have to traverse the subarray in n squared time, and also we have to calculate the sum of each subarray, which is n. So that will give us a total of n cubic time complexity. So this is destined to be time limit exceeded. Okay, so how should we do this? Since for subarray problems, we're basically intuitively thinking of sliding window solution, but for this, it's a bit tricky to define whether to move or shrink. Okay, so but since we're dealing with sum, we think of PrefixSum. Okay, so how can we solve this problem with the PrefixSum solution? Let's take a look at example here. So I'll erase this part. Now we still have this subarray. We still have this original array, and the PrefixSum. Let me put it this way. Okay, so if we have something here, the PrefixSum will be 23, and then 24, 25, then 29, 35, and then 42. Okay, so we can calculate the modulate of each PrefixSum. Okay, so this will be 5 based on k equals to 6, and this will be 1, and here we will have 5 again. So we can stop right here. What does it mean? So if like 23 modulated by 6 equals to 5, and we can now calculate its latest index. Okay, so the latest index so far is 0. Okay, let me put it over here to see more clearly. Okay, so the index is 0. Okay, and next we have a PrefixSum of 25 modulated by 6 equals to 1, and now the index will be 1. Okay, and after that we have 29 modulated by 6, which is also 5, and now the index comes to 2. So what does it tell us? If we have the same remainder here, that means the elements between these two indices will have a modulated remainder of 0. Okay, so that's what PrefixSum tells us. So in this sense, we can just save this in a hash map and see if we have encountered it before. If we encounter the same remainder again and we have a length of at least 2, we will find our good subarray. Okay, so yeah, with that said, let's code it out. Let me write it down here. So map stores PrefixSum modulated by k and the last index, or maybe the current index, but you get the idea. Okay, so now we can start coding it out. Integer, we'll have a new hash map, and we don't have to put anything in there. Okay, we just have to initialize a PrefixSum, and we can start iterating in the array. Okay, so PrefixSum will add nums I to calculate it, and we have the first case here. So if we have, like, say we have something that is already the k, the multiple of k. For example, the first element is 24. Okay, so that doesn't suffice because there's only one element here. But if we have like 24 and 6 at the same time, and its length is 2, and its remainder after modulating 6 is 0, so that satisfies our condition. Okay, so the first will be I is larger than 0 and remainder is equal to 0. Okay, so if I is larger than 0 and PrefixSum modulated by k is 0, we can simply return true here. Okay, second, if we don't have something for the remainder is 0, we can start putting it into our hash map. Okay, so other scenarios, let's say if map doesn't contains key PrefixSum modulated by k, we can just put it in there. Okay, map.put PrefixSum modulated by k and I. Okay, and if we have that, if map contains this PrefixSum modulated by k, and we have to satisfy the condition, the length is at least 2. So that means our current index minus map.get PrefixSum modulated by k is larger than 1. In that case, we can return true as well. Oh, sorry. Yeah. Okay, like that. Return true. Okay. Otherwise, we can just return false at the end. So the second condition will be length is larger than or equal to 2 and same remainder. Okay, let's put it that way. Yeah, let's try to run it. Okay, I think it passes the test cases here. Let's analyze the complexities. So for this, we're traversing the subarray, traversing the whole array only once. So it will be on. And for space, in the worst case, we're going to save all the prefixes in our hash map. So it's going to be on as well. Let's submit it. Okay, perfect. It passes all the test cases. Thank you so much for watching. If you like the video, please like and subscribe to my channel. I'll see you in our next video.